Okay, so my name is Mary O'Brien. I'm a consultant at One Spatial, specialising in the FME product set. And today wanted to give you an introduction to the FME Desktop product. So if you have any questions, can you add them to the chat window as we go along, and then we'll look to deal with them at the end. Okay, so here's what I'm planning to cover. It should be about 40 minutes or so. So we'll start with an introduction to FME and One Spatial. Then I'll explain what FME is and how it works. And then we'll look at what FME can do and explain that by using some examples and some demos. And then we'll finish up with 5 things I think are great about FME. So let's start with a little background. So FME is produced by Safe Software, and they're based in Vancouver on the west coast of Canada. And they have a network of partners across the globe with resellers in lots of countries, and they've also got a very active user community. So here at One Spatial, we've been an FME reseller for quite a while now, and we provide support for all of the FME products. So we have a team of skilled FME people. So if we can help you with any FME related questions or problems, then please do get in touch. The kinds of things we do, well, we provide training, both public and private training courses. We provide support to customers through our support portal. And we also provide consultancy services on the FME product set. So if you're interested, or if you're having any problems getting started with FME, or you're wanting to get the most from your FME workflows, but you're not quite sure how to do that, then please do get in touch with us. It's fme@onespatial.com, and I'm sure we can help. So there are a number of FME products. You've got FME Desktop, and that's the main tool. It runs the processing engine on your local machine. And it's what we use to build our logical business processes to manage your data. And that's what we're using here today. Then we have FME Server, and that gives you the ability to run those same processes at the enterprise level. So with multiple engines processing data in parallel. And then we have FME Cloud, which gives you FME Server, but from a hosted cloud environment. So without the overhead of infrastructure and maintenance, and so on. But it's the FME engine that's common to all. So when we build our data workflows in FME Desktop, as we'll do today, then that workflow can be applied to the other products as needed. So what is FME? Well, it's a really powerful data manipulation tool. FME stands for Feature Manipulation Engine, and really that's the best way to think about it. It's a processing engine for your data that lets you convert between hundreds of different formats. And it does this so well because it understands those formats. It's semantic, so it understands the specifics of each format and their limitations. And while it hides most of the complexity from the end user at one level, it still gives you complete control over the translation. So you have complete control over how your data gets from A to B, from BIM to XML, for example. And it's also a fantastic data transformation tool. So enabling you to define logical processes to apply to your data in a user-friendly workflow interface. Excuse the dog barking in the background. So when I'm talking about data transformations, I mean all kinds of data transformations. So changing the schema of your data, calculating some data values, doing some geometric calculations, or integrating data from all different sources. So FME gives you all the things you might expect from an ETL tool, but just packaged in a really nice user interface. And FME has a couple of licensing options. So the default is the node lock license. This is the most commonly used really. And that's tied to a particular machine, so only that machine can use the installed FME software. But you've also got a floating license option, so where the license or licenses are maintained by a license server and then they're served to the client machines. So in this scenario, you could have FME software installed on multiple machines, so everyone in the team, and then the license is shared between them, so that when one user starts FME, they effectively grab the license from the license server and they can use it. And that's using the FlexLM as a software tool as a license server, and you may already be familiar with that from some other softwares. The license also controls the level of functionality that's available, and these are known as the FME Editions. And so they increase in functionality, starting with the base edition, which is a really cut down version of FME, so a limited set of formats that you can access and a limited set of transformations are possible. And in fact, we generally don't recommend this edition, but instead suggest that most people start with the professional edition, and this gives you access to most of the formats and gives you the standard set of FME transformers. If you then want to write to Esri or Intergraph formats, you'll then need the Esri Edition license, and this gives you access to everything that was in the previous professional edition, plus the ability to write to Esri and Intergraph formats. Similarly, the Database Edition gives you access to everything in the previous, plus the ability to write to databases such as Oracle, SQL Server, or IBM DB2. And finally, the Small World Edition gives you the added ability to write to Small World files. And that's the top tier, so you get everything at this license level. Okay, so if you're wondering, FME is available on multiple platforms, and you can access the installers from the SAFE website at the URL at the bottom here. For most of us who are using Windows, you've got options for 32 and 64-bit FME. But if you prefer to work on Linux or Macs, then you can install FME there also. And if you've got a 64-bit operating system, then we generally recommend that you install 64-bit FME and take advantage of the extra resources available on your machine. It used to be the case that 64-bit only had a limited selection of formats, but in recent years that's no longer the case. But you should still be aware that there are some file formats that are only available on one or the other, 32 or 64-bit. So if you need to check formats that are of particular interest to you, then have a look on the formats matrix on the SAFE website, and the URL is there. Or feel free to get in touch with us and we can help you, so fme@onespatial.com. Okay, so once you've installed it and you've licensed it, what have you actually got? Well, there are a number of applications within the FME Desktop product. FME Workbench is the main one, so it's the primary tool for authoring workflows, defining those translation and transformation processes. The FME Data Inspector is another key tool that you can use to view data, so any of those 400 plus formats can be viewed through there. You also get the FME Quick Translator, and that's a little bit like FME Lite. So it lets you run some simple format translations or to run existing workflows, but without seeing any of the complexity. So that can be useful when you have some colleagues who simply need to push a button to run the process. Another useful tool you get as part of the desktop product is the integration console. And that simply lets you extend the format capability of FME into some of your other GI applications, like Esri, MapInfo, or AutoCAD, for example. So that means you could open any of the FME supported formats from inside your AutoCAD application, for example. So it's really quite powerful. And finally, you can optionally install some software development kits to enable you to extend FME, if that's where your skills and your interests lie. But the main tools we're interested in are FME Workbench and FME Data Inspector. So let's take a look. So if I'll just go get my Data Inspector, and I've got some CAD data that I'm interested in, so I'm going to go and get that CAD data. So here I choose the format I'm interested in, so I'm choosing a DWG file. But you can see when I choose more formats that I get access to the full gallery of formats that are available to me. So very powerful. So I'm interested in this CAD file, and it's this buildings footprints file. If I click the parameters, you can see some of the controls that you have on the data. And this data set is now being read in. It's loading the data. In here I can see I've got a map view, I've got some layer information on the left hand side, I've got some tools across the top which are allowing me to do things like zoom in on particular areas and maybe select particular features. And then it's an AutoCAD file, so I'm not getting any real attribute data, I'm not getting any tabular view. But I can see in this feature information window some extra information about the data set. So I get some AutoCAD specific information, and I get extended entity data here. So this is how the AutoCAD file is storing its attribution. And then down the bottom I'm getting some detailed information about the geometry also. So that's the data inspector. Just a very brief introduction to it, but it's really giving you access to all those formats and allowing you to inspect them and understand the data that you're working with. So now I want to take a look at the main tool, which is FME Workbench. And this is where we're going to create our workflow processes. So I'm going to start with some data translation processes, so translating data between our different formats. And again, I've got some simple demos that I'm going to use. So this is the FME Workbench application. We've got a main canvas here, and I'm simply going to use this shortcut to generate a workflow for me. So I specify my reader format, which is my input, and my writer format, which is the output, and that defines the translation. So the data set I'm interested in is a map info file. So I'm going to search for map info, and you can see I've got a number of different map info options. I just wanted to point out there is a new file, the new map info extended tab file, and that's now supported in FME 2017. So if you're a map info user, that's great news, because it means you're no longer restricted to the 2 gigabyte file limit on your map info files. And it's also more efficient, so it reads and writes data more quickly than the standard tab file format. So if you're a map info user, then definitely go check it out. I'm going to use it here to read my data set. So I've got a data set here of parks. It's in tab file, and I'm going to write it out simply to a CSV file. So I tell it where I want it to go. I'm happy with that. I click OK, and it goes off and builds the workflow for me. So I've got my input data and my output data, and my data will flow along this line and get translated. And there we go. So if I go and check that output, it says parks file, I can see that I've now got a CSV file originating from that tab file. So very simple translation, very easy to do. Let's try that again, but this time let's choose a different format. So I've got my parks file, and this time I'm going to write the same data out to an Esri shapefile. So I'm simply altering this to say I want to write it out to a shapefile, and it does it again for me. But this time it looks quite different, right? Why is that? It's because of the limitations of the shapefile format that we've chosen. So shapefiles are restricted to just one geometry type per file, point, line or polygon, whereas MapInfo is not. And as we said earlier, FME understands the specifics of each format, and that's displayed to us here. So it's helped us out and added a geometry filter transformer through the process to ensure that when we write out our shapefiles that they're valid. Okay, so that's how we might use FME to do a simple translation, but as we've just seen, we often need to manipulate the data in between also. And that's where the real power of FME lies. It's in the transformation capability. And transforming or manipulating the data is often more important than translating it between the different formats. In fact, the most common workflow built by users is from shape to shape, so with no format translation, just purely focused on transformation. So what do I mean by transformation? Well, it's the ability to manipulate the data, so analyze it, change it, create new data. And there are two types of changes we might do. So we can change the structure, the schema of our data sets, and by this I mean we can change what layers we have and what structure the data has in those layers or tables. And we can change the content of our data, so the geometry or the attributes. So we might create geometry from coordinates we have, or we might calculate new values from our attributes. And this is done with transformers in FME, so these little blue boxes of logic that we can see. So if we take a look at a few examples to try and understand what we can do. If we have donut geometries in our data, so maybe lake features in the real world represented in our data, then we could use something like the donut hole extractor to split those donut geometries into their constituent parts, the outer shell and the inner hole, and do whatever calculations we then want with them. A common task for people is to generalize their data. So you might want to remove some of the geometric detail but without losing the shape. And there are a number of standard algorithms to do this. In FME, you can access those algorithms through the generalizer transformer. If we think about how we might want to transform our attributes, then a common task for people is to build new attribute values based on the existing ones. So in this example, we want to concatenate a bunch of address lines into a new attribute. So like what you might do in Excel or SQL. And in FME, we can use a string concatenator or an attribute manager transformer to do that. And if you work with data with coded references in your data, then you could use an attribute ValueMapper, and that will allow you to map the coded values to the descriptive values. So in this example, we've looked at some data from OS Master Map, and we want to convert the feature code number to the English text in the descriptive term, and that's to make it easier for the end user to understand. So you could use the attribute ValueMapper to do that. And there are lots and lots of transformers to choose from, and you build your transformation process by stringing these transformers together into a logical workflow. So now we're going to take a look at a few simple examples of where we do that. So I've got three different examples to show you today. I wanted to try to do some simple examples using different kinds of data rather than focusing on anything that's particularly complex. So hopefully this will give you a broad overview of the functionality or the kinds of data that you might want to work with. So over to FME. And this is the FME Workbench product, and I've defined my workflow here on the canvas. And you can see I've strung together transformers and I'm reading in a particular format, an Excel file, and writing out to a CSV file here. So the first thing I want to do is inspect this data. So I've got some address data here. You can see it, just a few samples of address data with some names, addresses, IDs, postcodes, and so on. So that's my input. And what I'd like to do is perform some validation on this data. So I'm using an attribute validator here to perform some simple validation tests. So things like, what type must the ID be? I'm saying it must be alphanumeric. The ID must have a value, so I can't have any null values in there. And it must be a unique value. I'm also then testing that the values in the name attribute are strings and they're uppercase, and phone and postcode must have a value. So lots of little tests that I can build in this one attribute validator transformer. Any data that passes along my workflow. Any data that fails those tests, I'm writing out to an inspector here, to writing it out to something that I'm identifying as bad data. I'm then using a string searcher parameter, or string searcher transformer, to do more validation tests. So I'm then doing a stricter test, if you like. So here I'm testing the value that's in the phone attribute with a regular expression to test the syntax of that data. And finally, I'm using a custom transformer here. So this is one that we've built and it's freely available on the FME website, which is checking the syntax of the UK postcodes. So I'm stringing together a group of transformers to try and validate some data. So if I press play on this and have a look at some of the results, so we can see here some of the bad data that's been identified and the reasons that they've failed. So I can see my attribute phone check fails because there's no data there. This record fails because the name value is not uppercase, and so on. Okay. So now that I've identified good data and bad data, I can send that bad data back to somebody to fix it. I can build some routines to fix the data in FME. But I've identified the good data, and the good data here, I'm building a new attribute called full address, and I'm just concatenating the address fields together. So now that I know the address data is good, and only when I know it's good, will I go and build the full address data set. Okay, so that's one simple example of what we might do to validate some non-spatial data. The next example I have is looking at some vector geometry. So the scenario here is that I've got some contour data and somebody has given me a refresh of the data. And I now need to refresh our master holding, but I'm not sure what's changed. So I want to use something like the change detector transformer to identify what's different. So the change detector, I pass it the original data and the new contours that I've received, and it will identify for me what's not been changed, what's been added and what's deleted. And I'm defining change as any changes in the 2D geometry. I could also include attributes here, but I've chosen not to. So when I run this process, it's reading in all the data, the original data, and the revised data, and then comparing those two. And what we've got is highlighted here in red are the contours, the data that's been removed, and green are the new data, so the added data. So these are the records that have existed in the old data and have since been deleted, and these are the new records. So great, that's a really simple tool that's done a really good job here. But if we take a look at the new records, so these green ones, we can see that there's no elevation on these contours. So that's a problem for us. What we do have though is some labels, these little label points, where the elevation value has been recorded. And what we're looking to do here is to fix our newly added contour lines by identifying the nearest elevation point and assigning that contour line that elevation. And that's what we're doing in this section of the process. So I'm reading in the labels, the label points, and then I'm using a neighbor finder transformer so that for each of my new contours, the newly added contours, I'm then finding the nearest label and attaching the elevation to it. The other thing you'll notice here is that I'm enabling flow lines. So things I had previously disabled here just for the demo purposes, I'm now enabling very simply, and it means it's very easy to test, isolate parts of your workspace to test, which is another nice feature. So if I set this to run again, we'll see that the same process happens. So the exact same process happens every time I run the process. So my added contours are identified, and if I turn everything off and look at the correct ones, these have now got an elevation value added to them. Okay, and then just a final step. So once I've identified and performed my fix here, a final step, I'm just adding some styling. So I know I'm writing my data out to MapInfo here, and I know MapInfo stores styling. So I can use something like a MapInfo styler transformer to then specify the colors and the fonts and the sizes and etc. that are used on that data set. Okay, my final example is using some raster data. So here the idea is that I've got a particular site of interest And that's sitting in a CSV file, so it's just some X and Y coordinates, but it's not got any geometry. And I then want to identify or clip an area of interest around that site out of my raster holding. So my rasters are coming in here as a GeoTIFF reader, and I'm going to go get my sites out of the CSV file. So I'm going to add a reader. I'm choosing the CSV format. And it's my sites CSV file here. So if I have a look at the parameters, and we can see that it's simply one site at the moment with an X and Y coordinate. And here I'm choosing to specify that these are actually coordinates, and this means FME will interpret that and build the geometry for us, so build a point geometry as it reads the data in. So if I disable this flow line for a second, and I'll run my process so that we can see the two data sets that we're working with, so the raster and the site of interest that I've identified here. So what I'm looking to do is clip an area of this raster out to send it to somebody or to use it in a report, whatever the scenario might be. So I've got my site data, and what I'd like to do is then buffer that, because I want to identify an area of interest around it. So I can buffer that by, here I'm using 100 meters, and I'm then using another transformer, a bounding box replacer, to square it off. So I'm getting a circle around my point, and then I'm going to square it off. And then I'm using that as the cookie cutter, the clipper feature, to clip against my raster photo behind. And that's what we get. So we've got our site. We then generate a buffer. We then square that buffer off, and then we clip the raster out from that, and our end result, the clipped image, is the area of the orthophoto that we were interested in. So while that's great, it's always set to a particular value, so we're always buffering this by 100 meters. Wouldn't it be nice if we could use this same workflow to repeatedly produce these output areas, but to different sizes? And that's possible. It's very simple here with FME. We would want to alter the amount that the buffer is using each time that we press play on the process. So we can do that through publish parameters. So a parameter is published so that it can change at every runtime. So here I just find that parameter, and I can create a user parameter for it. I'll just use all the defaults for now. But this means that if I run my workspace, aware of this, and now alter this value at runtime, we'll now get a much bigger resulting image. So we've now gone out to 250 meters radius around that site. Okay, so that's one way that your processes can be very repeatable, and there's different options for how you can build them to make them generic in this way. So the final thing I wanted to do is to output this data. So at this point I'm just inspecting it at each time. What I'd now like to do is output this data. I'm just going to set it to go and then explain what's happening. So here what I'm doing is I'm using a feature writer transformer. So I'm using a transformer to write the data. So that's quite new. It's in the last couple of versions that's been available. So I'm writing that out to a JPEG format. So we're doing our translation here, and I've got options around compression and world files and so on. But more than that, we can then upload that file to another location. So here I'm simply uploading it to a Google Drive folder, but this could be somewhere on your network, or it can be somewhere like on a OneDrive system. And that's using a connector transformer, and these are fairly new. So in the last year or so that there have been a bunch of connector transformers that you can use within your workflows to connect and either upload or download data from different places on the web. And then final step I want is, well, to email myself. So when this process is run, I want to send myself an email so I can tell that it's run, that I can finish for the day, if you like. So yeah, so lots of options for how you might extend and notify and place data in different locations. So there we had a look at some non-spatial data and some transformers that we might use to validate that. We've had a look at some vector geometries and how we might do some change detection and correction of data. And then finally we've looked at some raster data and how we might clip areas out of our raster data, write it out to different formats, place it on different locations and notify us at the end. So lots of different options. And hopefully that's given you a little insight into what FME can do and given you some ideas to think about with your own data. But I really am just barely scratching the surface here, so that the possibilities are endless. So if you have any data challenges that we haven't covered here today, then please do get in touch and we can take a look with you. So to finish, I wanted to share with you some of the things I think are great about FME, so why I think you should go and explore it further. So first one, it's logical. So as we've seen, you define a structured logical process using those transformers as your building blocks. It's automated, so those logical processes are repeatable. You just push the play button and it runs again. It connects your data, so whether your data is stored in databases, file servers, online storage, web services, you can integrate all those sources into your workflows. And not only can you potentially link applications within your workflow, you can also try potentially link applications within your workflows. So you can use scripting to make calls to other tools via the command line. Oops, that hasn't quite displayed. And this one's one of the most important for me. It's got a very friendly user interface. So as you've seen in our examples, you can annotate your workflows with comments and organize it into bookmarks. And that's great because it means anyone can read and understand your workflow. So it really helps with collaborative working. And a final one, just because I couldn't leave it out, is that the FME software is in continuous improvement. So a new version is released every year, and there are generally 3 dot releases or service packs throughout the year, but it's in a continuous beta cycle. So this means that FME can improve with every release, and it can also adapt. so to new technologies and to new formats very quickly. And I think that's really important to know. So if you're interested, the new 2018 beta is available right now on the SAFE website, so go and check it out. And that's it from me for today. Thank you for your time and attention. If there are any questions, please post them and we can take a look now.